Hey guys, so before we start going over how to do each one of these review questions, I just wanted you guys to take a look at all the formulas that will be relevant to us on this upcoming test. If you're not sure what any of them mean, I will be going over them in a video that I'll put a link to in the description. Let's go to the first question, which should be number 2 in the packet. Alright, so first let's find the force. I'm going to use Coulomb's law. Force is a magnitude, right? So it doesn't really matter whether or not you put like a negative for the electron and a positive for the proton. Really, in the end, it's still just going to be indicative of the direction that the force is in. So the force is going to be equal to 8.2 times 10 to the negative 8 newtons. It's pretty straightforward. Now for the work, we know that work equals force times distance, and in an atom of hydrogen, we're told that they need to be this far apart. So that's really simple. I'm just going to take this previous result and multiply it by 5.3 e negative 11, because that's how, that's sort of like how, well, I don't know, it works. And then it gives me 4.3 e negative 18 joules. All right, question number 3. We're given 3 charges. We're given the charges of 1 and 2. So these are not in kosher units. Honestly, you could probably do the whole problem without converting them to coulombs and meters, but I like to do it with the standard units. So we need to first find the electric field strength. And based on the principle of superposition, we know that the total E is just going to be the sum of all the other electric fields that are involved. Here's the electric field from 1. You can see that it continues to go sort of like that way. And the electric field from 2 goes directly to charge 3, so we're going to label that E2. And we know that this is 45 degrees. So now to add these vectors, it's best for you to just break them up into their x and y components. The electric field of point 1 is already horizontal, so we can get that really easily. And I'm going to be using the formula kq over r to find this. This is the charge of 1. It doesn't matter what the charge of 0.3 is when it comes to this electric field formula. I just need to use the charge of the point in question. And I get that E1 equals 5,400,00 newtons per coulomb. Okay, now for E2, let's get to a smaller pen. Wait, can I give me a moment. I'm going to clean up some things. Okay, I had to clear some things so that we had some working space. So I'm going to break up E2x into its x and y components. So this is going to be E2 cosine 45. This is going to be E2 sine 45. And we also know that cosine 45 and sine 45 are equal, namely on the unit circle they're going to be root 2 over 2. So we can set them equal to each other. I'm going to use the charge of 0.2 here. This is the charge of 2. And again, divide by the distance. In this case, the distance is going to be 0.02. How did I get this? Well, let's go over here. You can see that this is 0.1. This is 0.1. By Pythagorean's theorem, this is going to be root 0.02. But because in the formula I need to use r squared, and I just want to square this, I end up getting 0.02. So then I solve for that, and I get this massive number. So now that we know both E1 and the two components of E2, we just have to add them up by Pythagorean's theorem. Alright, so now to find the force. Force is just E times Q. And we know that Q3 in this case equals 3 times 10 to the negative 6. So we know the magnitude, which is 22 times 6 newtons when we multiply that all out. However, remember that when we find force, force is a vector, meaning that it has direction. So we're going to use the formula tangent of theta equals y over x. For y, we're going to use the y component, which we already got earlier. And then for x, we're going to use the x component, which is here. And for that, I get that theta equals 14.6 degrees. Alright, so let's do the next question. So we want the forces that these two charges exert to be equal, right? And they're both positive, and the charge that we're going to put is going to be negative. So we want these forces to be equal. So I can cancel out the k's, definitely. I can cancel these out. I think I can pull out the e minus 6 from everything, though. That will get rid of some annoying powers of 10. When I combine all the like terms and everything, that gives me negative 36x squared minus 28.8x plus 8.64 equals 0. X comes out to be 0.23 meters. Alright, so we're on to question 5 now. We're doing it, guys. Let's set this direction as positive. The total electric field is going to just be the sum of all the already existing electric fields. So E1 plus E2. And we know that electric fields are basically F over Q. So I'm going to put this KQ1 over R1 squared, and if this is, let's say this is E1, let's say this is E2. If this is E2, then that would be going the opposite way, right? This is positive, so we're going to subtract that. Q2 over R2 squared. And you know that R1 and R2 are the same. They're both 15 centimeters because we happen to be right in the midpoint. So I can factor out a whole lot of things. So I end up with KR1 squared times Q1 minus Q2. So that gives me negative 1, 2, 0, 0, 0. And this negative sign really is just to show the direction. It means that we're going this way. So we can just write that as towards the left. Don't waste your stupid points on a question like this. Alright, question number 7. We're given the electric field here, as you can see, and we know that's F over Q. We want to find the acceleration, and since you know F equals ma, A equals F over m. So then if we can just find F, that would be great. So we can see from here that F is going to be equal to EQ, and then we're just going to divide this by m and we get acceleration. Now let's do the second part of the question. We already found A, and we're indirectly given VF because that's the final speed we want to reach, right? VF is going to be 10%, so that's 0.1 times the speed of light, which is represented by the letter C, which is equivalent to 3 times 10 to the 8th meters per second, right? And then when you multiply that out, that works out to 3e7. Let's use the formula VF equals VO plus AT. We're going to assume that VO starts at 0. And then from this, we can rearrange to get that T equals VF over A, and that equals 5.7 e negative 11 seconds.